In problem number 1, we'd like to design a clipping circuit which will pass voltages above minus 0.25 volts. So any voltage that's above minus 0.25 will pass. Anything below minus 0.25 will be clipped. And we're supposed to use a precision diode circuit. There are two parts to this problem. The first part is to develop a precise minus 0.25 volt supply. And the way that is done, we would take a Zener diode and we would connect this end to ground, and now in the Zener current will be flowing in this direction. And what we'd like to do is to pick a Zener diode, and at random, a good choice seems to be from the what's available in the table, to use one that is a 6.8 volt Zener diode. It's just an arbitrary choice, 500 milliwatts, and has a Z sub S equal to 5 ohms. That's a good choice. So if this is ground and this is at minus 6.8 volts, then I need a voltage divider that will cause the voltage at this point to be minus 0.25 volts. So I'll call this resistor R1 and this one be R2. And I see that since this is ground, this is the same as ground over here, and this is minus 0.25 volts, I can say that the 6.8 volts multiplied by the voltage divider ratio, which would be R1 over the sum of R1 plus R2, must equal 0.25. I could put minus signs on both sides, but it wouldn't make any difference. So from this equation, I have really two unknowns, R1 and R2, so it's not possible to solve for both of those. But if I proceed, first of all, if I multiply both sides through by 4, I have on the left-hand side 27.2 times R1 over R1 plus R2 is equal to 1. So that 27.2 R1 is equal to R1 plus R2. 26.2 R1 is equal to R2. Well, that's as close as I will get to a mathematical solution. So just pick some numbers. And a good choice, not the only choice, but let's pick R1 equal to 18K. If I did that, then R2 will be taking this value divided by 26.2. I get 472 kiloohms. Let me restate that. R2 is 26.2 times R1, so I need to multiply the 18K by 26.2 to get 472 kiloohms. So there I have it. I have R1 and R2, and as you can see, when you're doing a design problem, the answers are very seldom the same from one person to the next because of the fact that we all make different assumptions. But so far, so good. Well, at this point, I've selected R1 and R2, but the problem isn't finished yet because I was told in the problem statement that I'm working off of a minus 12 volt supply, and that is, well, I guess that's not really true. I'm just going to assume I was working off a minus 12 volt supply, and I have to knock this down to minus 6.8. So I put in a resistor in here. This resistor, I'll call this one R3. And I'd like to find a value for R3. Well, one way of doing that is let's solve for the current that is flowing through the resistor R2 in this fashion, and also